2012, number 84. So we're given a domain, so we want to make sure we enter that in our calculator. We're given a derivative, and we want to know concave down. When you read concave down, you should think second derivative negative. All right, so we're just going to graph the second derivative and find where it's negative, find the region. So that's the plan. So I've already put in the first derivative that they gave us. Now, I've recommended this before, I don't know, but somewhere I would, ahead of time, I do it at y8, put in the derivative of y1. So we just do math 8 to get derivative, enter y1, at what values of x? We want the derivative at all values of x, so we put it at x equals x. So I want to graph that. So notice this equals highlighted. That means I will graph that. But I don't want to graph my y1, so I'm going to go to that equals, enter. Notice it's not highlighted. That means it's only going to graph my derivative. Now I go to Windows. It told me from negative 1.5 to 1.5 already. Negative 1.5 to 1.5. So I'm going to go ahead and graph that. I want to know when it's negative, because when the second derivative is negative, so what are we doing here? I'm graphing. That's the first derivative right there, y1. This is the derivative of y1, which is the second derivative. So when I graph it, where is it negative? We can see to the left of that place and between here and here. So that's about 1-ish, right? Because this is 1.5. So kind of left of negative 1 and between 0 and 1, roughly. So it looks like this one, D, just from looking at it. We want to make sure. So this is left of negative 1 and between 0 and 1. But let's double check our intersection points. So how do I do that? Again, I do second calc. Now 1 is 0. That's where it crosses the x-axis. Guess to the left. Now you can move this blinky bob to the left of that crossing point, and then guess again to the right, and then move it over. Bam. So it crosses at negative 1. So from negative 1.5 to negative 1, it's going to have the second derivative will be negative, meaning the function is concave down. Now let's find this intersection point, that's 0. So I just want to put this to the left of that crossing point. Now it says right bound, so to the right, guess. And so that's pretty much 0. If you go 15 spaces to the left, that's 0. It's just probably it's a calculator error. Sometimes the calculator messes up when you're using exponential functions and things because it's approximating. It doesn't have an exact value. It uses something called Taylor series to approximate those. So that's 0. Because again, it's to the negative 15th power. If you move this decimal 15 spaces left, 0.00000000576, that's just 0. Okay, and then we want to find this one because it's negative between here and here. That should be 1 because we looked at our answers. But let's go ahead and calculate that, the 0. And we're going to put this to the left. Oops, too far. Left boundary. That's a right boundary. That's my guess. And that's, see again, 0.9999995. You round that off, it's 1. I'm guessing again that calculator is making a mistake. It's actually 1. So it's from negative 1.5 to negative 1, and 0 to 1 is our answer. So here we go. There is the answer.